Hello, welcome to my video presentations. In this video, I will describe the final projects that I have finished in this year, detecting notes on guitar string without any audios. In the beginning, let me outline the structure of these video presentations. First, I will introduce the executive summary of these presentations. Secondly, the background and overview of the entire system will be described. Then, the methodology of the program will be presented, and the result of the testing as well. Finally, the issues and the improvement will be considered and discussed. Nowadays, guitar is one of the most popular musical instruments. Before playing the guitars, firstly, the instrument needs to be tuned. There are many different brands of guitar tuners that are easy to purchase. And there are some useful tuning apps that can be installed in the phone and easy to be used. Most of these apps and devices identify the music notes by the frequency of the audios. However, sometimes there may be many sound noise that will affect the programs. For example, many instruments are playing simultaneously or in a noisy environment, which means the audio source will be very noisy. As shown in this video clip, if there is a loudness with other sound, the tuning apps is not working well. Meanwhile, there are some people have uploaded the videos that the guitar strings are curved while the guitar is playing. This is because of the rolling shutter effect of a camera with rolling shutter. Therefore, the propagating wave can be clearly recorded in each frame of the video and possibly to be analyzed while visions. So, here is an alternative way to solve these problems, which using the basics of computer vision, edge detection of images. As the vision can just focus on one instrument, the influence of other instruments can be mostly ignored. There are two main types of shutter used for camera, rolling shutter and global shutter. The global shutter will take all the pixels of the photo simultaneously. In opposite, the rolling shutter will take lines of pixels of photo at once, so that if the shutter moves faster than the wave oscillations, the wave will seem to be still on the guitar string. In this project, the shutter speed is set to 4000 Hz, and it is faster than the highest frequency notes in the guitar, which is around A50 Hz. The notes that test here is G4, A4, B4, and C5, which is in 392, 440, 494, and 523 Hz. This video just shows how rolling shutter of the camera works and how the object is curved. Here is a difference of guitar string vibration recorded with and without rolling shutter effects. The input of the system will be the video that recording the guitar string vibration with the rolling shutter effects. The output of the system will be the letter that represents the notes. Here is the example of the output for the systems. Moreover, several assumptions we will make before starting to navigate the systems. The program will analyze the video in offline. The strings are recorded in the middle position of the video approximately and considered to be fixed position. There is one note detected at once only. Here is the overflow of the entire system. The sections will be discussed in the further part of the presentations. To produce a binary images that only contain most of the significant points, canny edge detection is required. Firstly, a Gaussian blur will be implemented into the images with a Gaussian Carnot matrix by convolution. Then gradients of the images will be calculated by implementing the Sobel filters in both x and y directions of the blur images. According to the magnitude and orientation of the gradients, non-maxima suppression and thresholding will be applied to make the edge thinner by eliminating the elements in the direction of 45, 135, 225, 315 degrees. The line objects will then be created by Hall transform. Once more of the convolution by Sobel filters in x direction will be applied to weaken part of the horizontal elements. Besides, thresholding will be used for eliminating most of the elements in horizontal. Before applying the Hall transform, the data will be filtered after edge detection. In these binary images, 0 elements are 0, which represents the black pixels. The maximum of the non-zero elements is 1, which represents the white pixels. As some points are non-zero, but they are very small, which will affect the calculations of finding filter threshold. The average of non-zero data points will be found first. Those values that are smaller than this average will be reassigned to zeros. Then the median will be found and set as the threshold. The values below this threshold are assigned as 0, and the values over this threshold are assigned as 1. The median can find the more appropriate threshold that separate a set of data without outliers. Afterwards, once more of the convolutions is applied in x directions after this filtering, so that the horizontal components can be mostly eliminated, and the vertical components will be enhanced as well. Hall transform algorithms is used for detecting straight line on the images. The distance from the leftmost of the images to the center of the lines will be computed, and the angle between the line and the vertical directions will be computed as well. The basic theory of the Hall transform is to convert the straight line into a r theta plane. For a linear function y equals to mx plus c, which is a straight line in the xy coordinates, the points in the line will be converted into mc coordinates. A set of two or more points in the r theta plane that forms a straight line will produce sinusoidals for that lines. Those as the ends and the rotation of straight lines objects will be computed and stored. The strings can be rotated and placed vertically. Also, noise or unnecessary data can be eliminated by just filtering the horizontal elements. The filter images will be cropped according to the position of the string detected as well. The height is depending on the maximum length of the detected strings, and the width is dependent on the range of the strings. The cropped images is compressed with sampling weights along with the directions of strings, which takes the average of a certain number of rows and using this means of rows to represent this group of rows. Thus, the identifications for each string will one fewer data points, and the execution efficiency will be increased to a certain extent. For the aim of detecting all the string locations, using loop statement to go through all the rows so that the amplitudes of each string can be defined. Also, since the string is not in one pixel width, all the column will be gone through to detect the strings. If the index of y pixels is not continuous in horizontally, star point of the width of the string start counting and be stored, while the index is continuous. If the index is continuous, endpoint of the width of a string start counting and be stored, while the index is not continuous. Afterwards, calculate their middles and put their column index into an array, and eliminate the repeated data and sort. Since the vibrating string has the largest peak-to-peak value compared with other strings, the vibrating string will be detected. By substituting the record peak-to-peak data back into the images that just detected and cropped, the index of the pixel of the individual string are found. Also, the middle point of the waveform is calculated and stored, so that the difference between the index of individual string and the middle lines of the waveform will be calculated and stored as a set of magnitude of discrete signal. Although the waves can be extracted clearly, they may not be a complete end-to-end waveform. Before building up the entire database, the wave in each frame will be plotted, and the clearest wave will be selected. The maximum and minimum of this waveform will be defined. The interval between these 2 points will be copied and split to produce the waveform that has at least one complete period. To find the best match of two waves, dot product for the two waves can be used, since the waves are stored as a vector with sampled amplitudes. As the detected waveform may not have the same phase as the waveform stored in the database, the detected waveform will keep phase shifting and find the maximum dot product with the waveform in database. Compare the results that the detected waveform matches with all the waveforms in the database. The maximum will be the best match, and the notes played on the detected waveform will be identified based on the database. Besides, the absolute value of the vectors will be used, as there may be best match when the detected wave and the database wave in upside down. Moreover, the waveform will be normalized before matching, since the amplitude of each waveform may not be the same. The video clip is showing the skirmish of how the testing video are recorded. The directions of the wave propagation should be as the same as the directions of rolling shuttle movement. The rolling shuttle is sensing the photo line by line, from up to down. Therefore, the movement of the rolling shuttle is in the vertical directions of the camera. The wave propagation is perpendicular to the directions of the finger steer the strings. Hence, the wave is transverse and propagated along the guitar strings. Thus, the guitar string should be placed in vertical in camera coordinates, or the camera is placed horizontally. One of the most effective factors is the lighting to the guitar. When the shutter speed increases, the frame will become darker due to the shutter exposure time. Firstly, additional light is tried to be used. However, this lighting is concentrated and directional. The main part of the string will not be lighted up, and the two finished strings are hard to be detected. If this light is applied on the main part of the strings, since the two finished strings are silver, the reflection of the string will be strong, and the strings are still hard to be detected clearly. There will be only a small range that will be light up and detect as well. The onset and offset of the notes means the stage of the note's start and end. As the function detecting the onset and offset of the notes is not developed yet, the testing process will be operated by estimating the approximate frames that the notes are operating. The approximate frames will be estimated by the time that the note is playing in the video over the total duration of the video. Then, this ratio will be multiplied by the total frames which has been defined by the program. Most of the tests are processed on the string of a 6-string guitar in standard tone. There are several tests are done and the data is shown below. In comparison, the higher frequency note has better performance in darker natural lighting. Further distance between camera and guitar can enhance the performance on lower frequency notes. The same notes placed on another string has the similar performance, which means the system is robust for the function of converting the vibrating strings to digital waveform, and also the matching functions. In considerations, another reason that cause the low accuracy will be the estimation of the notes in the video is not appropriate. Some notes are detected continuously in other note durations and not be detected in its durations. Despite that, the accuracy is in 30% approximately. To conclude, the musical notes on the guitar strings can be detected without voicing. The frames are converted to binary data via edge detections. Then the data is analyzed by the algorithm that developed. However, the accuracy is not such high, which several issues making influence and some improvements that can make in the future. In the future, firstly, the onset and offset of the notes will be defined. Since the distance between each string can be defined by the data that compute via Hall transform, if all the gap distance are similar, all the string will be considered as still. In other words, since the digitized waveform has been produced, and based on the maximum and minimum of the waveform, the virtual period of the waveform can be produced as well. Also, the gap distance between strings can provide a calibration so that the distance between cameras and guitar will not affect the results significantly. Therefore, the database can be simplified since only the number that represent the periods will be stored, and there will be less errors in building up the database as well. Moreover, the ISO setting can be considered to adjust, so that the program can still work in the dark environments. Besides, the program can work on other string instruments such as violin as the calibration is developed successfully. That is the end of my video presentations. Thank you for your watching and listening.